dealt with a lot of things, actually. We did with the grade 11 content, and we dealt with these issues of compound angles, you know, when they say determine this, and being able basically to see that you actually have to apply a compound angle of some sort, right? So with that being said, let me just quickly be consistent with my, I just want to be consistent with where I was, you know, okay, compound angles. And then I can teach you double angles. I actually had given you a homework. So maybe to just quickly revisit and also help other students, specifically in this scenario, the likes of, let's see. Okay, were you, Karabo, I did not add you into the thing. Ne? I think I added you, Karabo. Did you receive my email, Karabo?
But I couldn't join.
No, you just have to log in. You couldn't watch the video. Okay. Maybe it's your internet, man. I see. Lord, do you use Wi-Fi?
Yes, sir.
Yeah, I think your Wi-Fi is extremely fast. Eh? I'm not sure. Yeah, sometimes, but then I'm working on it, Karabo. I'm trying to reduce the size of the videos. The reason why you couldn't join because the video is quite big. Okay. So the ones with strong internet and good like devices that open things fast. So if you couldn't join it with your phone, you know, if you can try to open with an iPhone if you have, or open with a laptop which is like a bit faster, or any laptop really should be able to open it. One. Yes. Just make sure that you log in with your email when you join the room. One. Exactly. So, Andy, so I'm gonna add you there. I just have to go back and see if I copied your email right, or maybe you did not type your email right, but I want to believe that is correct. Anyway, let's look at this question here. They said, it is known that this, so you're given this sine alpha minus 5 equals to 0. Every time when you're given something of this nature, you want to first simplify it, agree? Before you even go any further. You want to simplify this. So you're going to take the negative 5 to the other side. And then sine alpha is equals to 5 over 13. So you want to do that. And then they say, you are given for that. So let's just write that. And you are given that for tan B plus, didn't we do this question? I'm not sure. No, we didn't. I know we didn't. 3 equals to 0. And then you then simplify this. You take the positive 3 to the other side, will be negative 3. Then you divide by 4. Did I lose anyone there? Did I lose anyone there?
Sir.
Okay. Please tell me if I lost you. Okay. Good. So now let's look at the conditions. These conditions are very important. They say where alpha is an element of that. So alpha is an element of 90 degrees to 270. And they're saying beta, you only need 2 conditions really to locate these things in a quadrant. Happy there, guys?
Yes, sir.
Okay. So before you can answer this, you want to draw what we call the Cartesian plane for these 2 situations. Okay. Every time when you get an information like this, especially when they give you conditions, when they don't give you conditions, your triangle will always be in the first quadrant. Always. it will always be in the first quadrant. So now let's look at this one here. So sine alpha is 5/13. So sine alpha is positive. Do you see that? It's positive, right? Right?
Yes.
Right?
Yes,
So
sir.
5/13 is a positive number, it's not a negative number. So where is sine positive? Let's locate that.
The first
Sine
and the
is
second. Oh, sorry.
positive here, it's positive there. And this one? Now, they say alpha must be between 90 and 270. Where's 90? 90 is here. This is 0, 180, 270, and then 360. So 90 and 270 is this. That means it's either this quadrant or that quadrant. But then where is sine positive? Sine is positive here. So it's this quadrant they're talking about. Okay. So we must locate this information in this quadrant. Are we together, guys? Are we together? It's a right angle triangle.
No.
Your alpha is there. And then, what is sine? Sine is an opposite over hypotenuse. What is the opposite of this angle? The opposite of this angle is this side, agree? Agree?
Mhm.
So that is 5. Hypotenuse would always be the longest side. 13. So before you answer this question, you want to solve what is this value here. Are you happy?
Yes.
How are we going to solve this value here, Karamo?
Pythagoras.
Okay. And this is the x
Pythagoras.
value. Exactly. So, and that's the x value. So we know that Pythagoras says that r squared, which is the hypotenuse, y squared, x squared. What is my r? My r is 13. What is my y? My y is 5. What is my x? I don't know. And then that is 169 minus 25 x squared. And then you see that that is 144 x squared, which then lead us to, you are going to square root. So when you square root, it's always plus or minus. Square root of that is plus or minus 12. The question is, do we take the negative 1 or the positive 1?
Negative.
Okay.
Yes.
Why do we take the negative 1?
Because it's on
Because
the negative
of the
side.
two.
Because x, this side is negative. So that is negative 12. Are you happy, Andy? So there? Andy, so? Can you hear us, Andy?
So please check your WhatsApp. So she's answering on WhatsApp because
Okay.
I think she might be having sound problems. Oh yeah, she's having network problems.
Okay. Let's quickly look at the other part. Let's look at the other part. Where do we look at the other part? Tan is positive. Where is tan positive?
Negative, sir, in the second and the fourth.
In the second and the fourth quadrant, right? In the second, no. Tan is negative. It's okay, yes, it's
Yeah.
negative on the second and the fourth.
Negative, yes.
And where is it positive? That's the way that I wanted to ask.
In the first
okay.
and the oh sorry.
Yeah.
So are you writing something on the screen or
No. So tan is positive on the third and the first. But then 90 to 270 is only choosing quadrant number 2 and 3. So that means we must locate that. Oh, but then here they want negative. Sorry.
Negative.
So where is tan negative? Tan is negative in quadrant number
2,
3, 2, and 4.
4.
So we're going to have to locate this information in quadrant number 2 because 4 is not included. That means we must draw a separate Cartesian plane because it's also in quadrant number 2, this information. If it was not in number 2, we're going to draw just one Cartesian plane. Okay. And then that is beta. So tan is opposite over adjacent, agree?
Yes, sir.
Tan is opposite over adjacent, right? Right. And then we know tan is opposite over adjacent. So now, what will then this look like? So opposite of beta is this guy. So that is 3. Be mindful of the fact that I did not put this negative because y here in this side is positive, right? So rather the x will be the one that takes the negative because x is negative here. Question is, how do I get this one? You should know this one by head. What is the answer to this one? What is this one?
5.
It's 5. You should know that one by head. Use Pythagoras. Okay, it's fine. Now that you have this, then you can answer everything that is questioned. Okay. Okay, good. So let's just quickly look at the questions that are asked thereof. They say we must find cos A plus beta. Cos A plus what? Plus beta. Cos of A see, quite tricky. But then what are you noticing here, guys? Cos A plus beta, what do you notice? What is cos A plus beta?
Compound.
It's a compound angle. So you have to first expand that. Cos beta, cos A beta. But then remember for cos, if this is plus, this will be but minus.
Yes.
Minus.
Sine alpha to understand what is cos alpha from this diagram. Okay. Cos alpha from this diagram is adjacent of a hypotenuse. What is the adjacent of alpha here, Karabo?
12, negative 12.
So that would be negative 12 over 13 because it's adjacent of a hypotenuse. So that would be negative 12 over 13. And then cos beta is from this triangle. That is negative 4 over 5, agree?
Yes.
Negative 4 over 5. Look, guys. Negative 4 over 5. Okay. And then this one here will be minus sine of alpha will be uh, 5 over 13. Opposite of adjacent. Opposite of hypotenuse. 5 over 13. And then sine of beta would be 3 over 5. And then you can simplify this using your maths and stuff. Trust me, they say don't use a calculator, but here you can punch this in the calculator, get the answer, punch that in the calculator and get the answer, and then add them together using a calculator and get the answer. They're interested in you being able to do this. Are you happy there, guys? Are you happy?
Yes, sir.
So I'm not gonna do, guys, the approach is the same. This one use the same approach. You expand that, you expand this, you expand this. Are you happy?
Yes, sir.
Yeah, so this here, this one here, the approach is the same. I'm more interested in number E. Okay, wait, can I ask, is there anybody who doesn't understand that? The approach is the same. You expand these double angles and then you substitute, right? The approach is the same. I'm more interested in number E. Number E, let's look at number E. Number E is asking for tan of beta minus alpha. So how do we get tan beta minus alpha? Because we do not have a compound angle of tan beta minus alpha. Eh?
Sir, why can't we just say, just like minus that and then just 10 that?
I don't understand.
Like, sir, get the 10 of beta minus the 10 of alpha and then just...
No. This is not equals to tan of beta minus tan of alpha. It's not. Okay, that is not the case. Just like that is not the same as cos alpha plus cos beta. Do you hear me? This is not the same as cos alpha plus cos beta. You don't distribute it.
Okay, sir.
What? So who wants to give a try?
Sir, I mean, 10 is the same as, isn't it the same as sine beta over alpha over cos
Yeah,
beta
it's the
over
same.
alpha?
So what must we do? So we must change this to a ratio in terms of sine. So that is sine of beta minus alpha over
Cos beta
cos
minus
of
alpha.
beta minus alpha. Are you following, Andy? So, Andy, so you must unmute and talk. Okay. You must allow your mic. You must learn how to allow your mic because you must interact here, or use another device to join. It's important that you interact. But anyway, so now that you're here, so what are you gonna do? You're gonna expand this on its own and then do the same for the other one. So that would be sine beta cos alpha minus sine alpha cos beta. Like is the sine one. I get it. It's a sine compound angle. Same thing. The bottom cos beta sine alpha. No man, cos beta cos alpha for cos, remember? But because it's a minus, it must be positive. And then these things are there in the formula sheet, eh? Sine beta sine alpha. And then you take this, all of this, from these things, right? From this thing, right? And then put all of those information and get your answer. Are we happy there, guys?
Yes.
Yeah. So let's look at number F, which is quite interesting. Number F, I think we are given sine of alpha minus 300. And then minus cos beta minus 150. If you are smart enough, you should be able to notice that actually 150 is more of like a special angle of some sort. But then there's no need for that, for you to see that. Whichever way you choose to do it is still fine. Right? But then it's important for you to highlight to see 150 is more like a special angle. Because 150 can be written as 180 minus 30. Remember that, guy?
Yes, sir.
And 300 is also a special angle. Because 300 can be written as 360 minus what? 60. Okay.
Okay.
But then I'm not there. What I want us to first do is to do what we call, because then this is some sort of a difficult question. Let's do a compound. Let's expand this because we can't simplify this. If this was theta minus 360, then we will use the reduction formulas. But we can't use reduction formulas because these are special angles. So we can't use the reduction formulas. So we need to expand this. Okay. Ne?
Yes.
Yes, sir.
So this will be then sine alpha cos of what? 300, okay? Minus cos of alpha sine of 300, okay? Minus, I suggest you put this in the bracket because the minus will affect everything inside the bracket. Now, this will be cos of beta, cos of 150. I'm applying the cos compound. This is a sine of beta and then sine of 150. So you're almost done. Now, when you are here, what do? Sine alpha, you can take it from the graph, but then you don't want to do that now. You want to first simplify these special angles. Cos of 300 can be written as what? 360 minus?
Minus 60.
And then
60
I'm not
minus 60.
so I don't want to.
60.
Cos of 300 is the same as, you can't say 300 plus 60. 300 plus 6 is 360. So whatever that you put in the bracket must take you back to 300. So you must write 360 minus 60. Are you happy?
Yes.
So what is that? Which quadrant is 360 minus 60?
Quadrant number 4.
Is cos positive or negative in quadrant number 4?
Positive.
So this is the same as cos of 60. So here I'm going to put cos of 60. Are you happy there, guys?
Wait,
Yes.
sir. So where did you? Oh no, never mind, sir. Yes, sir.
Let me explain this, guys. I was supposed to write another step of this. Actually, let me just do it so I don't confuse you. Let's do it. This is the same as cos of 360 minus 60.
Right.
Minus cos alpha. This is the same as sine of 360 minus 60. Right? Minus, and then you put in the bracket, cos beta. This is the same as what? 150. How do you write 150 in terms of boundary angles?
180 minus 30 or 90 plus, yes, 180 minus 30.
180 minus 30. Plus sine beta. Same thing, 180 minus 30. Right. And then now we can simplify these things. This is the same as sine alpha. Cos is positive in quadrant number 4, so that would be just cos of 60, right? Minus cos alpha. And then now, what is 360 minus 60 is quadrant number what? Number 4, right? But then, and sine is negative, right? Notice
Yes.
that when sign becomes negative, the negative will multiply this negative here, and then this will become positive. So that is sine of 60, right? And then minus, put bracket, and then cos of beta. Then here, the cos will be quadrant number 2. 180 minus 30 is quadrant number 2. So this will be negative cos of 30 plus sine beta. 180 plus 30 is quadrant number 2, but sine is positive in quadrant number 2. So that will be sine of 30. Are you happy? Are you happy?
Yes, sir. But sir, can I please just write this down? Okay, yes, sir.
Okay. Now, this then becomes sine alpha. What is cos of, sorry, let's just take the sine alpha from the graph, from the two graphs. Remember sine alpha was what? 3 over 13, even from here, 3 over 13. Or you can take it from here, opposite of a hypotenuse, which is 3 over 13. Then you substitute there. 3 over 13. No, man, 5 over 13. Why do I say 3? And we know cos of 60 is a special angle, so that is a half, right? Cos of 60 is half, it's a special angle. Can punch in the calculator, still fine as well. And then plus cos of alpha, you can take it from the graph as well. Cos of alpha is adjacent of hypotenuse, negative 12 over 13. Are you following, guys? Cos of
Yes,
60 is root 3 over 2 minus, and then you put this in bracket. Cos of beta, you can take it from the graph here. Adjacent of hypotenuse, negative 4 over 5. Negative 4 over 5 times cos of negative cos 30 is the same as negative root 3 over 2. You can punch that in the calculator if you've forgotten the special angle. And then plus sine of beta opposite of hypotenuse, 3 over 5. Sine of 30 is a half. Okay. And then from here, you can punch this in your calculator. It's up to you. Then you can do the maths. 5 over 13 times half is the same as 5 over 26. This one here is the same as negative 12 root 3 over 26. Minus here, it's the same as positive. Negative times negative is positive. 4 root 3 over 10. The other one is going to be 3 over 10. Are you happy, the guys? Are you happy?
Yes, sir.
Okay. And then you can
But-
simplify. Yes.
Oh, no, I didn't see the brackets. Yes, sir. No, it's fine.
And then you can simplify this work, obviously. Okay. You can just do your calculators and then simplify these things. Are you happy, the guys?
Yes, sir.
Are you sure?
Yes, sir.
Yes, sir.
Okay. Let's have a look at this one now. At the double angle. Firstly, I want to explain to you how do you solve double angles. Okay. So let's look at sine double angle. Okay, compound angles. Please don't forget on how to solve these things. I hope you guys remember these things. When they say evaluate cos 75, ne? Remember, I said you can use what? Boundary angles, special angles. I taught you these guys. Please don't forget this. You're gonna have to maybe revisit this note sometime or the work sometime.
But sir, that video, when I opened it, it's no longer available. Did you delete it?
I'm gonna retrieve everything, don't worry.
Oh, okay.
Okay, the final answer there, you can just punch it in the calculator and this one. I'm really not so concerned about the final answer. I want to believe that everyone can punch this in the calculator and get the answer. All right. Okay. So I want us to quickly, I'm more concerned about you being able to apply the method, okay? So now I want us to look at double angles, right? Guys, all of these things are techniques in answering trigonometric questions. And now we're gonna look at when do you apply these techniques, when you're approving, when you are changing things, you're gonna have to think about these things, okay? I'm gonna do a lot of this. I think this section I'm gonna take quite a long time for maths. And in the coming few weeks, unless otherwise we are meeting with the other group that we meet tomorrow and Sunday, me and you, I think, will be purely doing maths, you know. Okay. So now, how do we solve double angles? Please, let's look at sine double angles.
Sorry,
we know that
Captain,
sine.
I couldn't hear what you said.
Okay, we know that sine of 2a is the same as 2 sine a cos of what? Of b. Do you see that?
Yes.
Do you see that? Do you see that, guys? What about, yes? Your sine A. What do I say B there? Sine B, sine A. Yes? Can you guys hear me?
Yes. Gary, when the 2 is before the sine, it's still sine 2a. If it's 2 sine a, it's still the same.
I don't know why sometimes my Zoom give ups on me. Eh?
So before it cuts, what were you saying about I don't remember. So
I was saying about the double angles. I was starting to talk about double angles.
okay.
So can I ask how if the 2 is before the sine a, that it's still the same as sine 2a?
Yeah, if you find 2 sine a cos a is the same as sine 2a. You need to be able to go back and forth.
Without the cos, it's saying unalo cos. If it's just 2 sine a, height one.
They're not the same. No, they're not. Okay. Please be able to know that. I think there's something I need to teach you as well. There are a few things that I need to teach you that I want you to look out for. Ne? What about sine 4a. What is sine 4a?
Isn't it 4 sine A 2 cos A? I mean cos 2A.
This is what you want to do. Every time when you have an angle like this is the same as sine of, you do this. Look at this, 2a. Do you see that?
Yes.
Do you see that? Do you see that, guys?
Yes.
So instead of having an a here, you're going to have 2a. So it's basically the same thing. You're going to have 2, but then you're going to have 2 sine what? 2a, and then cos of 2a. Are you happy there?
Yes.
Yes, sir.
What about sine of, oh wait, by the way, you can also further simplify this. Sine 2a can be simplified again further, okay? Okay? Ne? Because sine 2a is the same as 2 sine a cos a. Are you happy there, guys?
Yes, sir.
Okay. So, the last one, what about sine 8a? What is sine 8a?
So, and this was asking, why can't you just put 4 in front of the sign?
No, you can't put 4 inside of the sign, because when the 4 is here, what is affected is the angle, not the 2 still remains the 2. You don't put the 2 there. Okay. That's why you see here, I said sine 4a. We can write 4 in terms of a, like 2 times 2a. Do you see that?
Yes, sir.
So our reference has got to be this one. There's got to be 2 times a certain angle. Are you happy? Let's look at sine 8a. Sine 8a is the same as what? Let's put the 2 again. The same as what? 2 times what? 2 times?
4. 2 times
4a.
4.
2 times 4a. Do you see that? So now, the angle now is 4a. It's no longer a or 2a. So the 2 will still be there. This is sine 4a cos of 4a. Are you happy there? Do you see that, guys? The 2 is still there. Do you see that?
Yes, sir.
Yes.
Are you happy there? Everyone?
Yes.
Are you sure?
A.
Are you sure, guys?
So before signing it, it's always supposed to be 2. Can you not put the 4 there?
Sometimes you can have the 4,
put
but then
them
no,
in.
you don't. You don't put the 4 on the basis of the fact that this is 4 or this is 8. No, this only affects these angles. Ne? The 2 will still be there. Are you happy? Are you happy?
Yes, sir.
So you don't say
So you're
8
cutting,
sine
I
8.
can't hear you.
Yeah, I'm saying you don't say 8 sine 8 cos 8. No. It's not like that. Doesn't work like that. Okay. And we're gonna prove this. We're gonna prove this. Don't worry. I'm gonna show you how this is proven. Ne? Now, let's look at this. Now, let's look at this. So this is a lot of the cases, right? What about the following? Let's work backwards now. 8 sine of a cos a. If you look at this, the moment you see sine a cos a, you must always think about 2 sine, right? But then you want to always reference back to what the original one says. Ne? Do you see that? Do you see that?
Mm.
So in this case, it's 8 sine A cos A, right? So you want to reference this. You want to use this as a reference to solving or simplifying this. So what you want to see 2 sine A cos A, but here you have 8 sine A cos A. So how do you want to do this? You want to split 8 into this thing. 8 is the same as 4 times 2 sine A cos A. Do you see that? Do you see that? 8 is the same as 4 times 2. Do you see that?
Yes, sir.
Do you see that, guys?
Yes, sir.
And then you can then now clearly see this gentleman here. Do you see that gentleman there? What is that gentleman? What is 2 sine A cos A?
It's a double angle identity.
Which is what?
Sine 2.
And to a
That means this is the same as 4 sine 2A.
Oh, okay.
Are you happy?
Okay.
Are you happy there, guys?
Oh, so
okay.
because we see an 8, sine 8 doesn't work like that. Ne? Okay.
Yeah, no. Okay. Now, I want us to look at this one now. What about this one? What is sine A cos of A? When you look at this, what is missing from this and that?
Sure.
It's the 2. Do you see that?
Yes.
So basically, this then becomes, if you look at this properly, if you look at this, ne? You can see clearly that if I divide by 2 both sides, this side becomes sine 2A over 2. And then let me just put it this way. This is the same as that. Do you see that? This we agree. 2 sine A cos A is the same as sine 2A, agree?
Yes, sir.
But then if I divide by 2 both sides, sine A cos of A becomes half sine of 2A. Do you see that?
Yes, sir.
Do you guys see that? Because I
Yes.
divide by 2 both sides. So please be mindful of the fact that sine A cos A is half of that. Or how you want to always do it, if you are moving from cos A sine A, you always want to divide this number by 2 and then change this to sine 2A. Let's look at this. 8 sine A cos A, divide 8 by 2, it becomes 4. But you know sine A cos A is sine 2A, right? Right? Are you happy there, guys?
Yes.
Okay. Now, that is quite like important for you to see, you know. And then I want us to quickly look at something. How do they derive this? How did they derive this? This was derived from this formula. Sine of A plus B is the same as what? Sine A cos B plus what? Cos, let's just say sine B cos A. And then now they say let A be B equals to A. Are you happy there? Are you happy
Yes.
there, guys?
So are
Let
you
B-
proving?
We are
Are
proving the
you prov-
identity.
Okay.
And how you
Is
prove
it
the identity, you make these two angles the same. You use compound angle to prove that identity. So you're
so?
gonna let
Sir,
B to, yes?
is this the question they usually like?
Yeah, prove this, but normally prove, they say prove the identity of sine 2A and stuff.
Okay. Okay, sir.
Okay. Are we together?
Yes, sir.
Okay. All right. Let's quickly look at this. So we're gonna let B to be A. So that means we're gonna have sine of A plus what? Plus A. Are you happy there? Are you happy there?
Yes.
In another words, this is sine A cos of A plus sine A cos of A as well, because every angle is A. Then A plus A is 2A, so that is sine 2A. You will notice that sine A cos A is the same as 2 sine A cos A. Do you see that? You guys see that?
Yes, sir.
Yes, sir.
That is the same as that. So we just say 2 sine A cos A. It has been proven.
Oh,
So you use the compound angle to prove this double angle of sine. This is the same also for cos as well. Okay. So I've showed you the techniques of the double angle sine. Okay, a double angle sine. Very important, this double angle. Okay. How to move from the double angle itself to go in there when the angle is bigger, and how to move backwards to compressing it, you know. So now let's have a look at the cos one. The cos one is 3 identities. Let's just do it by proving it. And the cos identity is very important for us to understand. There are a lot of things that I want you to see here in the cos identity. Okay. Cos, double angle. This one has 2 identities. Yeah? So it's cos, again, we know we have cos A plus beta, which gives us what? Cos of A, cos of beta, but then this becomes minus sine of A, sine of beta. The approach is the same. You let what? A to be B. Where there's going to be A, you're going to put B, or where there's going to be B, you're going to put A. It's just like that. So now let's see. We want to have cos A plus A. Are you happy? And then this becomes cos A. Where there's B, A beta, we'll put A minus sine A, sine A. What is cos A times cos A? Is cos squared A minus sine squared A. Cos A plus cos A is cos 2A. Do you see that? Do you see that, guys?
Yes, sir.
And guys, every time when you see this cos squared A minus sine squared A, might be teaching you something else. This is not necessarily related to the identity itself. It's for you to remember this as a side note. This is a certain type of a factorization or something here. Cos squared A minus sine squared A. What type of factorization would you use here?
Isn't it difference between two squares? I think.
Exactly. This is different of two squares. So these then, please put it as a side note to know that this is cos A minus sine A. Every time when you see this, just remember that. Especially when you're factorizing, when you are like simplifying and whatnot and whatnot. Quickly remember this.
Sir, isn't it plus minus?
Oh, plus minus. Oh, no. That's just a side note. It's not really an identity. It's just what for you guys to see. When every time you see this, just think about that. It becomes very handful when you are simplifying fractions. Okay. Now, with cos does not have one identity. You know, it's cos squared A minus sine squared A. But then I want you guys to remember these ones. Do you guys remember that sine squared A plus cos squared A? What is this? What is that?
1.
Sine is 1. So, which means sine squared A is the same as 1 minus cos squared A. Right? And so it's a cos. Cos squared A is equals to 1 minus sine squared A. Are you happy there?
Yes, sir.
Yes.
So, if this cos, the cos identity, it is defined is divided into 3. You can either have an identity of cos 2A, which includes both cos and a sine. And you can have an identity of cos 2A that only includes a cos. So if you want the one that includes the cos, it means you want to convert everything into a cos. So let's convert everything into a cos here. This one, I'm not going to change it. I'm going to leave it as a cos. But then I know that I can change sine squared A. What is sine squared A in terms of a cos?
So 1 minus, it's 1 minus cos squared A.
Okay. And then there you're going to have cos squared A. So remember, this was the first one. Minus 1 plus cos squared A. Then the like terms, you can add them. That becomes 10, that 2 cos squared A minus 1. Then this becomes the second. Are you happy there?
Yes, sir. Wait, sir, please, before you move on, sir. So what exactly happened here?
So here we are looking for another identity of cos 2A. I said there's 3 of them. One of them is it's there in the formula sheet, by the way.
Yes,
Cos
sir.
squared A minus sine squared A. So we want to write this in terms of cos. So I just change sign. Where there is a sign, I put 1 minus cos squared A.
Okay.
So if I want to change this one into a sign only, not a cos, from the very same first equation, where there is a cos, what am I supposed to put?
A sign. I mean, where there's a cos.
Where there's cos squared A, what am I going to put? I'm going to put sine. I'm going to put that in terms of a sign, right? What is cos squared A in terms of sine?
It's 1 minus.
And then that becomes 1 minus sine squared minus. Then you add these things together, it becomes minus 2 sine squared A. So do you see the other one is this one? Another one is this one here. And then another one is this one here. And you see, all of these ones, we have proven them. We have proven everything. So basically, we have proven that cos A plus A is the same as cos squared A minus sin squared A. Then we went to further on to prove how all of these is either that is either that. Why is it important? Why is it important for us to be able to solve these things? All right. It is extremely important for us to be able to know these things, because when you are solving or simplifying and you are given a cos 2a, you want to be able to either choose of these three, which is convenient for that particular or that specific question, You get me,
So
guys?
cutting, sir.
So the reason why we're using this is because, right? The reason why we're using this is because you want to choose something. You want to choose a question, not a question per se. What am I saying? The reason why I'm saying these three things are important. When you are simplifying, it's important to know which of 1, 2, 3 options do you want to choose as your identity, because you're allowed to replace cos 2 alpha with either that, or that when you're simplifying.
Okay.
Are we together?
Yes, sir.
Are we together, guys?
Yes, sir.
Yes.
Okay. Now, let's continue. Okay, let's continue. Now, let's have a look at give me a second. Let's have a look at how do we apply this, on all of those sorts of things. Okay. So the double angle. Let's look at this. All right. Let's cut this question. Yeah. Maybe okay, do it just right. Okay. Can you read that statement for us? Karabo, can you read that for us?
In the diagram below, reflex angle XOP is equals to theta. P is the point of -12 and T, and OP is equals to 13. Calculate without using a calculator.
So what you want to do first, you want to do the following. You want to write this triangle, complete it. Where is the -12 go? The -12, is it the Y or the X?
The X.
-12
No.
is the X, right?
It's
The
oh
Y.
yeah, yes.
The Y. X, sorry, it's X, you're right, it's X.
Yeah.
So this is -12, and then the Y is T. So I'm not gonna do the Y. Let's solve for T. Everyone, can you solve for T?
It's -5, sir.
It's -5. And why did you choose the -1?
Because it's on the negative side of the y-axis.
Exactly. Is it the negative side, right? It's on the negative side. So that is -5. Use Pythagoras, by the way. And this one is Pythagoras. So that. And then now, you see now they say solve sine 2 theta. But then in the question given, you don't have sine 2 theta. You know? So what are you going to do first?
So aren't you
Expand that to.
You want to
What's this?
expand this.
Two.
You want to expand this sine 2 theta. What is sine 2 theta, guys?
2 sine theta cos theta.
And then from this, you can locate what sine theta is. What is sine theta? Theta is here. It's opposite of hypotenuse. Do you see that, guys?
so?
And your opposite will then become -5/13. What is cos theta? Adjacent of hypotenuse. That is -12/13. Are you happy there, guys?
Yes, sir.
And then this one, how do we do this one? What are we gonna do, guys?
Gonna So can't you just use any cos identity here? Or do
Yeah.
you have to use one with cos and sine?
No,
Because
it's
of
up to
that
you, really. It's up to you. But I always advise you to use one. Like, choose the one that just considers one of them. Okay. Especially when like there's no pressure to do so. So let's choose a cos identity, yeah? That'll be 1 minus. Let's choose the sine one, maybe, or the cos one. It's up to you. So the cos identities that we have, remember, is cos squared theta minus sin squared theta, and 2 cos squared theta minus 1 minus 2 sin squared theta. So let's take the cos one. One may ask, say, why did I choose the cos one? The reason why I chose the cos one, I'm going to tell you now so that you guys also know. In the triangle, initially I can get a cos without getting the t because it is adjacent of hypotenuse. Adjacent of hypotenuse. So this value of t, I might make a mistake on calculating it. Hence, I would rather go with the cos. But then it's not really necessary, but it's just a pointer, you know, that I'm giving you. Ne?
Yes, sir.
So the cos one here would be 2 cos squared theta minus 1. But then plus 1 again. Don't forget, why did I do this? Is 1 minus 2 cos squared theta minus 1. Do you see that? They said I put it, but then there's a minus there, and the minus will affect this minus 1. With a tan 2 theta, I don't have, with a tan 2 theta, I don't have a specific, like, how can I put this?
Identity.
We don't have a specific identity. So what do we do? How do we solve it?
We use sine 2 theta over cos 2 theta.
Exactly. Sine 2 theta over cos 2 theta. And then this I can expand. Let's leave the top part. That would be 1 minus So 2 cos theta plus 1 over, and then sine 2 theta is 2 sine theta cos theta over the cos one. I can also still choose the other one, the one that I chose first, cos 2 theta minus 1. And then when you are here, you can put all of these values from this triangle here, because you know what sin theta is, cos theta is, and all of those things. Are you happy?
Yes, sir.
Are you happy there, guys?
Yes, sir.
Okay. Okay. So this is quite really important for us to know. Okay. It's quite important for us to know. So let's do this one. Should be our classwork. Can you take it as a classwork? Take it, everyone, as a classwork. You see, it's very important to follow the condition because it will give us these conditions.
So you want us to do the first 3 only?
Yeah.
Okay.
But then do draw the diagram. I need to see the diagram. Allow me to do this. Okay, because I don't want to lengthen the recording. I want it to be very small. So let's just continue. Andy, so are you working? So here, let's see. We have, guys, can you hear me?
Yes, sir.
Yes, so we can hear.
So your first step is to do this. Okay. So sine is positive here, but then we are told that this must be 90 to 270. So it's from here up until today. So sine is only positive here. So we need to put this in quadrant number 2 altogether.
Yes.
So this is x opposite of hypotenuse 8 over 70. And then how do we get this one? How do we get y? Always make sure that you solve the y, the x side, this part, not the angle per se, but the side.
It's Pythagoras, and you'll get minus 15.
Yes.
Minus 15. Okay. R squared, y squared, 17 squared, 8 squared plus x squared. And then that is the same as 225 when you take that to the other side, and then this becomes plus or minus square root of 225. And then this becomes negative 15. Why negative 15? Because x is negative here. And then now we can begin to answer all these questions here. Let's answer the first one. So what I want to do is sine to x. What must we do?
Expand it to 2 sine x plus x.
And then that is 2. And then sine of x is opposite of hypotenuse 8 over 17. Once you get here, guys, to this part here, you are more than welcome. And although they said don't use a calculator, they're not going to say that you don't use a calculator, especially here, you know. No one's going to tell you that you did not use a calculator or something, you know. Are we happy there, guys?
Yes.
Yes, sir.
So with the cos, obviously cos, you can change it into many things and it can still be right. Who wants to tell me what preferably, which one could I change it to preferably?
So I change it to 1 minus sine squared x.
2 sine squared x. I think it's 1 minus 2 sine squared x.
Mm.
It's 1 minus 2 sine squared x, unless if I made a mistake myself. Ne? It's supposed to be 1 minus 2 sine squared, yeah, minus 1, 2 sine squared. And then the question is, Karabo, motivate to us, why did you change it to 1 minus 2 sine squared x?
I thought, okay, it was an easier way for me to do it that way.
The reason why it was easy is because the information already gives us a sign. So you don't want to complicate your life and bring other things. Not to say it's incorrect to use other ones, but then it makes things easier because you know this is what you have been given. So changing this to a sign makes everything easier for us. So that is 1 minus 2. And you already know what sign is. It's 18, 8 over 17. Don't forget to square it there. Are you happy?
Mm.
Then you're going to get your value, the 1 minus 2, 64 over 324. Ne? Not sure. You can correct me there. And then you get your answer and all those things.
Yeah, so it's 289.
289. It's not 224, is it? Is it 18?
Uh, 324 is it was 18. So
You know, I used to know these things by head during my time, eh? All of them. Okay, so tan 2x, we know what to do, right?
Yes.
Sine 2x over cos 2x, and then sine 2x, you would have calculated it from the first one. You would have calculated cos 2x from the second one, so there's no need for you to expand anymore. What one?
yes, sir.
Okay. What about cos 90 minus x?
A compound. No, it's just
You don't have to.
it's gonna be cos. It's gonna be sine x.
Sine what?
Sine
Sine
x.
Yeah, if you like attention, you can do compound by the way. It can still work even if you do compound, but there's this reduction. 90 minus x, the reason why it's sine is 90, so the cofunction of cos is sine. So because of the 90, it changes sine x, and then you can do your shenanigans. And then here, this one is easy. Agree? You can just do compound here. But one,
Yes.
sine x cos of 45 minus sine 45 cos of x. Where do you get sine x? You get it from the drawing, right? Opposite of hypotenuse. Cos 45 is a special angle. You should know that. Right? Right?
Yes, sir.
And you do the same thing for cos of x plus 60 as well. Right?
Yes, sir.
So, just give me a minute.
London.
Yeah, just give me a minute. I'm here, guys.
So how the cos 45 special angle? Does that mean we're gonna write it as as that special angle? We won't use the diagram.
No, cos 45 is a special angle. Cos 60 is a special angle. Right?
We won't
Yes.
use the diagram to okay.
Yeah, for 45, you don't use a diagram. For 60, don't use a diagram.
Okay.
For 30, don't use a diagram. Even for 90 or 270 or 180, no. Okay. However, let's look at this one. Let's quickly take a bit of let's zoom into this one. This one, you know what to do, right? What do we do here?
Sine
What do we do?
over cos.
Sine over cos. What? So, ladies and gentlemen, we have done the basics of all of these things. Obviously, this one, I think we solved this. We just solved that. Okay, I didn't do this one because I didn't want to confuse you yet. I want you to feel fresh. And then we're going to be doing this one. This one, I'm going to give you some sort of a teaching. I think I've achieved my goal. I said we're going to have to have a lesson up until 11. And indeed, it's 11 now. and then we can safely adjourn to the class, and we're gonna finish these things. Yeah, and then we'll be fine. And then we'll be doing a lot of these things tomorrow. Okay. Tomorrow I'm gonna meet you for science later. We'll be doing work, energy, and power. All right.
Yes, sir.
Okay. So make sure I'm gonna be uploading these recordings in the classroom, and I'm